In this question, we need to find the angular momentum of a mass which is projected with speed u. So let's consider this is the ground, and the mass is projected in this way with initial speed u with the angle theta. Here theta is 45 degree. So the object will exhibit projectile motion, and we need to find the angular momentum of the object with respect to the point at which it is projected, and also exactly at the point where it is having the maximum highest point. Yeah. So let's consider this height as h max, and this is the point from which it is projected. So initially it has a speed or velocity u. This velocity can be split into two components. One is vertical component, it will become u sine theta, and horizontal component, it is going to be u cos theta. So at maximum height, the vertical component becomes zero. So only velocity remains is the horizontal one, that is in this direction, u cos theta. So how do we write the angular momentum? Angular momentum we can write it as uh, r cross p. We write like, or if you want the magnitude only, then we can write it as r perpendicular into p. So what is r perpendicular? It is a perpendicular distance between momentum and axis of rotation. So here axis of rotation is this point. You can consider axis of rotation is passing through this point, the point at which it is projected, and it is going into the screen. So the perpendicular distance becomes h max. R perpendicular is h max in this case. So at is point, the angular momentum is going to be h max into m into u cos theta. Now we need to find the h max. So we can use equation of motion. Initial velocity we know, final velocity we know, like I'm talking about the motion along y-axis. Then we need to find the displacement. And here we know acceleration is downward and it is g. So we can use the expression that is v squared minus u squared equal to 2as. So here v is the final speed, which is 0, and u is u sine theta. So it is u squared sine squared theta, and acceleration is negative g. So negative 2g h max. So h max will become u squared sine squared theta, sorry, divided by 2g. So we can substitute everything to find the angular momentum h max, that is u squared sine squared theta divided by 2g into mu cos theta. And we know theta is 45 degree, which is given in the question. So cos 45 sine 45 are equal to 1 by root 2. So I can write this as u squared 1 by root 2 squared, here 1 by root 2 whole divided by 2g. So what do we get? Mu squared divided by 4 root 2g. This is the angular momentum in the question. Root 2 is there on the top. So what I can do, I can multiply and divide with root 2. So this become root 2 mu squared by 8g. So if we compare with the question, it is written root 2 mu cube by xg. What will be x then? Going to be 8.